All right, we're going to look at two examples where we divide rational expressions. Just a reminder, if you are dividing any fractions, you take that division, change it to multiplication, and you flip your second fraction. So if you have more than one term and you have to divide rational expressions, you want everything in factored form. So I'm going to rewrite the problem. I'll zoom in a little bit too. There we go. This x times x minus 2, that is in factored form. So we're going to leave that alone. Over, now this x minus 1 squared, we're going to break that down into its two factors, x minus 1 and x minus 1. All right, now we take the division from the problem, change that to multiplication, and we're going to flip this second fraction so that we're multiplying by the reciprocal. So that x minus 1 is going to go on top, and on the bottom we have the x minus 2, but it's squared, so that means there are two of those. So x minus 2 and then another x minus 2. All right, in this example I'm going to show you kind of the long way or this next step I'm going to write out, and then I'll skip writing over this next step. So when you multiply fractions, you do multiply straight across. So if we multiply straight across, we're going to have an x, then we're going to have an x minus 2, and then times that x minus 1. In the denominator, we're going to have those x minus 1's, so we have two of those, times the x minus 2's. So I'm basically just putting everything together into one fraction. Now that I have everything together and I've got a lot of things separated by multiplication, all these separate factors, I'm looking for anything on the top that might cancel with anything on the bottom. So one thing on top can cancel with one thing on the bottom. So for example, here's an x minus 2 on top. It's going to cancel with that x minus 2 on the bottom. We have an x minus 1 on top and x minus 1 on the bottom. And you want to look to see if anything else will cancel. It might be tempting to take this x and cancel it with, let's say, this x right here. But remember, we've talked about in previous videos, if an x is connected to another term with a plus or minus sign, you cannot cancel this x on its own. It's stuck with that 1. All right, so what do we have left on top? We have an x. In the denominator, we have an x minus 1, and we also have an x minus 2. And this is going to be our final answer. We'll just leave it. We're not going to multiply anything out. We're going to call it good with that one. All right, so let's look at another example. Just by glancing at this, I can see that nothing's factored. So we're going to rewrite the problem and factor every part. And at the same time, we're going to flip the second fraction because this is a division problem. All right, so first we have 2x minus 1. There's no GCF there, and it's only two terms. It's not a difference of squares, so that 2x minus 1 is going to stay. Then we have to factor this 2x squared minus x minus 1. So off on the side, let's think about what's going to happen there. It's a trinomial with a number in front of your x squared, so this is guess and check. So remember, the first two have to multiply to your 2x squared. The second two have to multiply to a negative 1, which means one positive, one negative. So here's a positive, here's a negative, and then you just check. That gives you x, multiply these, that gives you a negative 2x. Do these combine to give you the middle term above? It does, so that is factored correctly. So I'm going to rewrite that. Factored, we have a 2x plus 1 and then an x minus 1. All right, times this fraction, we're going to go ahead and flip that. So on the bottom we have x squared minus x. I'm going to go ahead and take out a GCF because I can see that they have an x in common. Leaves me with an x minus 1. And then the denominator we have, I'm going to look at that separately, that 4x squared minus 1, that's a difference of squares pattern. What do we square to get the 4x squared? What do we square to get a 1? So 2x and 1, that's going to factor into 2x plus 1 and 2x minus 1. All right, so let me go ahead and put that in the problem, 2x plus 1 and 2x minus 1. All right, in the last example, I wrote out a step where I basically combined all this on the top, or almost like I smushed it together because it's all multiplication, and same thing with the bottom. So what I actually do, because it's multiplication, I just go ahead and make this one big fraction because I know everything on the top will end up being multiplied and everything on the bottom will be multiplied. And I'm looking for anything on the top that might cancel with anything on the bottom. So we see a 2x minus 1 here, which will cancel with a 2x minus 1. We've got an x minus 1 that will cancel with an x minus 1. And that's about it. So our final answer, in the numerator we have an x. And in the denominator we have a 2x plus 1 and a 2x plus 1. So we can just go ahead and say that's 2x plus 1 squared.